we introduce generalizing event-based motion deblurring in real-world scenarios. With the aid of low-latency events, recent event-based motion deblurring methods have exhibited promising performance. However, current approaches often assume the same spatial resolution of images and events as input. Ignoring images usually have larger spatial resolution than events in real-world scenes. To handle the spatial gap, a feasible solution is to utilize super-resolution techniques, but such cascaded scheme often produces noisy results due to the error propagation from one stage to another. Besides, motion blur with larger temporal scales or blurriness often causes performance degradation in practice. Compared with previous approaches, our method generalizes event-based motion deblurring in both spatial and temporal domains. Our approach can handle varying spatial scales of inputs without retraining or using additional SR models. Under different temporal scales of motion blur, our method shows robust performance and restores better details. To achieve this, a scale-aware network or SAN is designed to process different scales of blur and produce high-quality results. We first proposed the Multi-Scale Feature Fusion or MSFF module to enable flexible setup of input spatial resolutions. Given the extracted image and event features, MSFF module projects the discrete features into the continuous space via implicit neural representation. Afterwards, we fuse the features in the continuous space and refine them via deformable convolution. With MSFF, our SAN is able to fuse the information of images and events at different spatial scales. In the temporal dimension, we present an exposure-guided event representation or eager to learn from different blurriness levels of motion blur. We consider the exposure of target image L and represent the conversion process using events. Thus, our SAN can learn from different temporal scales of motion blur via blur-to-blur conversion, while maintaining the ability to restore sharp latent images via blur-to-sharp conversion. During model training, we develop a self-distillation method to generalize deblurring performance in both spatial and temporal domains. We first set a pre-trained SAN as the teacher model and use it to produce pseudo-ground truth from normal blur. Then, we synthesize large blur at different spatial scales and teach the student SAN model to handle these degraded situations. By contrasting different blurriness levels, our SAN gains better performance in tackling varying scales of blur, boosting performance in real-world scenarios. Now let's move on to the result part. We first compare our method to motion ETR under different spatial scales. One can see that the performance of motion ETR varies as the spatial scale of blur changes, while our method consistently produces high-quality results. Under different temporal scales, motion ETR degrades when encountering large blur, while our approach remains robust performance. Here is another example, and we can see similar results. We also compare our approach to EVDI under sequence restoration. With the help of eager, our method can produce arbitrarily high frame rate video sequences from blurry inputs even under complex motions. Lastly, we introduce our multi-scale real-world blurry dataset MSRBD, which contains 32 sequences of real-world HR blurry frames and LR events. We hope our MSRBD could facilitate the research of motion deblurring in real-world scenarios. Welcome to check our paper and GitHub page for more details. Thank you for watching.